A lot of different problems in a lot of different uses in a lot of different purposes. We're gonna talking about what it takes to appreciate them. Septic system were basically your private waterway system, and so you're protecting not only your personal drinking water but neighbors' drinking water and community drinking water too. Are you used to learn about bigger water waste plants? You didn't know smaller treatment system existed? These are pretty cool, because we're here to talk about on-site sewage treatment.
On-site sewage treatment, or OSST. Individual sewage treatment systems are used in areas not served by a community wastewater treatment plant. On-site sewage treatment, or OSST systems, traditionally called septic systems, usually consist of the building sewer, which leads from the building into a septic tank and then into a distribution box that feeds the fluid into drainage field or disposal field. Types of septic systems. Septic system design and size can vary widely from within your neighborhood to across the country due to a combination of factors. These factors include household size, soil type, site slope, lot size, proximity to sensitive water bodies, weather conditions, or even local regulations. Below are 10 of the most common types of septic systems used. First is septic tank, conventional system, chamber system, drip distribution system, aerobic treatment unit, mound systems, recirculating sand filter system, evapotranspiration system, constructed wetland system, and cluster or community system. So let us first talk about septic tank. A septic tank is a buried watertight tank designated and constructed to receive and partially treat raw domestic sanitary wastewater. Heavy solids settle to the bottom of the tank, while greases and lighter solids float to the top. The solids stay in the tank while the wastewater is discharged to the drain field for further treatment and dispersal. Your household liquid waste flows from the house into the septic tank, where the sewage undergoes a settlement process and is partially treated by bacteria. This partially treated waste then travels from the tank to a disposal or absorption field, where it is further broken down by natural processes. The type of disposal field depends on soil type and the slope of the section, vegetation, and underlying rock. Your septic system is a living ecosystem where bacteria do the work of digesting and treating waste. The septic tank retains fats and solids and releases the liquid portion of the waste. This liquid effluent flows into the disposal field and is further treated by the soil. A healthy septic tank is a well-balanced ecosystem where good bacteria thrive in the right amounts to digest waste and treat the effluent water. Second is the conventional septic system. It is a decentralized wastewater treatment system consisting of a septic tank and a trench or bed subsurface wastewater infiltration system, or what we call the drain field. It is a conventional septic system that is typically installed at a single-family home or small business. The gravel or stone drain field is a design that has existed for decades. The name refers to the construction of the drain field. With this design, effluent is piped from the septic tank to a shallow underground trench of stone or gravel. A geofabric or similar material is then placed on top of the trench so sand, dirt, and other contaminants do not enter the clean stone. Effluent filters through the stone and is then further treated by microbes once it reaches the soil below the gravel or stone trench. Gravel or stone systems are relatively large in overall footprint and may not be suitable for all residential sites or conditions. So how it works? Aseptic systems work by allowing wastewater to separate into layers and begin the process of decomposition while being contained within the septic tank. Bacteria, which are naturally present in all septic systems, begin to digest the solids that have settled to the bottom of the tank, transforming up to 50% of these solids into liquids and gases. When liquids within the tank rise to the level of the outflow pipe, they enter the drainage system. This outflow or effluent is then distributed throughout the drain field through a series of subsurface pipes. Final treatment of the effluent occurs here as the soil absorbs and filters the liquid and microbes break down the rest of the waste. Septic systems cannot dispose all of the material that enters the system. Solids that are not broken down by bacteria begin to accumulate in the septic tank and eventually need to be removed. The most common reason for system failure is not having these solids removed on a regular basis. When the holding tank is not pumped out frequently enough, the solids can enter the pipes leading to and from the tank. This can cause sewage to back up into the house or cause the drainage system to fail as the pipes and soil become congested. These problems are often costly to fix, pose a danger to public health, and are a significant source of water pollution. Sewage from inadequate or failing septic systems can contaminate both ground and surface waters. The industry recommends having a licensed company to clean your septic tank on a regular basis as preventative maintenance.
Chamber system. The chamber system serves as an alternative design to the gravel or stone system. The primary advantage of the chamber system is increased ease of delivery and construction. They are also well suited to areas with high groundwater tables, where the volume of influent to the septic system is variable. For example, at a vacation home or seasonal inn. In an area where gravel is scarce, or in areas where other technologies such as plastic chambers are readily available. This type of system consists of series of connected chambers. The area around and above the chamber is filled with soil. Pipes carry water waste from the septic tank to the chambers. In the chambers, the wastewater comes into contact with the soil. Microbes on or near the soil eat the influent. How it works. Septic tank works by allowing waste to separate into 3 layers: solid, effluent, and scum. The solid settles to the bottom, where microorganisms decompose them. The middle layer of effluent exits the tank and travels through underground perforated pipes into the drainage field. In 2-chamber septic tank, the wastewater enters the first chamber of the tank, allowing solids to settle and scum to float. The settled solids are anaerobically digested, reducing the volume of solids. The liquid component flows through the dividing wall into the second chamber, where further settlement takes place. The septic tank 3 chambers RS works by gravity of foams and fats and sludge. The incoming wastewater passes through 3 different rooms, and while within lightest materials date back to flotation, and heavier materials fall on the bottom of the tank. Drip distribution system. The drip distribution system is a type of effluent dispersal that can be used in many types of drain fields. The main advantage of the drip distribution system is that no large amount of soil is needed, as the drip laterals are inserted into the top 6 to 12 inches of soil. The disadvantage of the drip distribution system is that it requires a large dose tank, after the septic tank to accommodate the time dose delivery of wastewater to the drip absorption area. Additional components such as electrical power are necessary for this system, requiring an added expense and increased maintenance. How it works. The subsurface drip distribution system distributes wastewater through a system of tubing with flow regulating emitters. The tubbing can be installed at various depths below the ground surface. The pump tank stores the treated wastewater until it is dosed. A high head pump delivers the water from the pump tank through the filtering device to the drip distribution system. A control system regulates dosing to the drip fields. Most systems utilize a control panel to implement time dosing to the fields. This allows effluent to be distributed throughout the day in even doses. Control panels can also control automatic filters, backwashing, and field flushing. Some systems use demand dosing to the drip field with a manual filter and field flushing, but this is not recommended. The filtering device can be a sand filter, disc filter, or screen filter. Its main purpose is to remove large particles from the wastewater so they do not plug the drip emitters. Depending on the design system, the filter may have an automatic backwash for the filter devices that can be activated by the pressure differential before and after the filter or on predetermined frequency. The system can also have automatic, manual, and continuous field.
Next is aerobic treatment unit. Aerobic treatment units use many of the same processes as a municipal sewage plant, but on a smaller scale. An aerobic system injects oxygen into the treatment tank. The additional oxygen increases natural bacterial activity within the system that then provides additional treatment for nutrients in the effluent. Some aerobic systems may also have a pre-treatment tank and a final treatment tank, including disinfection to further reduce pathogen levels. Benefits of this system are that it can be used in homes with the smaller lots, inadequate soil conditions, in areas where the water table is too high, or for homes close to a surface water body sensitive to contamination by nutrients contained in wastewater effluent. Regular lifetime maintenance should be expected for aerobic treatment unit. Aerobic treatment units use biological processes to transform both dissolved and solid constituents into gases, cell mass, and non-degradable material. An important feature of the biological process is the synthesis and separation of microbial cells from the treated effluent. Process involves a variety of aerobic and facultative microorganisms living together that can decompose a broad range of materials. Organisms live in an aerobic environment where free oxygen is available for their respiration. Aerobic treatment units can be used to remove substantial amounts of BO5 and TSS that are not removed by simply sedimentation in a conventional septic system. Biological process also involves the nitrification of ammonia in the wastewater and the reduction of pathogenic organisms. Nitrification is the breakdown of ammonia to nitrate by microorganisms in aerobic conditions. Aerobic treatment units, which are certified as Class 1 aerobic systems, treat wastewater well enough to be used in conjunction with spray systems, which distribute treated wastewater over lawns, combined with disinfection. They are the most common way to treat wastewater for spray systems. Mound system. A mound system is an engineered drainage field for treating wastewater in places with limited access to multi-stage wastewater treatment systems. Mound systems are an alternative to the traditional rural septic system drain field, also an option in areas of shallow soil deep, high groundwater, or shallow bedrock. How it works. The mound system includes a septic tank, a dosing chamber, and a mound. Waste from the homes are sent to the septic tank where the solid portion sinks to the bottom of the tank. Effluents are sent to a second tank called a dosing chamber from which they are distributed to a mound at a metered rate. Wastewater is partially treated as it moves through the sand. Final treatment and the disposal occur in the soil beneath the mound. The mound system does not allow all the effluent to enter the mound at once, accordingly allowing it to clean the effluent more effectively and helping keep the system from failing.
Recirculating sand filter system. Sand filtration is used for the removal of suspended matter such as floating and sinkable particles. Then, how this recirculating sand filter system works. Sand filter system can be constructed above or below ground. Effluent flows from septic tank to pump chamber, then to sand filter. Effluent is defined as liquid waste or the sewage. Then the effluent leaves the pipe and treated as it filters through sand. The treated wastewater is then discharged to drain field. Evapotranspiration System. This type of system is used less in this day and age as the effluent produced is too contaminated for above ground and near surface application. Then how does this evapotranspiration system works? Septic tank system usually consists of septic tanks, which has a baffle that divides the tank. The settling process takes about 24 hours. Only the primary treated liquid or effluent found in the central level of the tank flows out of septic tank into an absorption field. The sludge and scum remain in the septic tank and must be periodically removed to ensure the system operates properly.
Number 9. Constructed wetland system. Constructed wetlands are engineered systems that use natural functions, vegetation, soil, and organisms to treat wastewater. Depending on the type of wastewater, the design of the constructed wetland has to be adjusted accordingly.
How do the constructed wetland system works? Wastewater from the house flows to the septic tank. As usual, it retains solid waste and fats, then it conveys wastewater down to the wetland cell. The wastewater then passes through the media and is treated by microbes, plants, and other media that remove pathogens and nutrients. The wetland cell typically consists of an impermeable liner and gravel along with the appropriate wetland plants, which must be available or be able to survive in a perpetually saturated environment. A wetland system can work via either gravity flow or pressure distribution. As wastewater flows through the wetland, it may exit the wetland and flow into a drain field for further wastewater treatment into the soil. Cluster or community septic system. Clustered systems can be as simple as a conventional subsurface disposal field shared by two lots and served by individual septic tanks or as a complex as neighborhood collection, treatment, and disposal system that is comparable in size and scope to a small municipal sewer system. Larger systems can also be installed to serve as industrial or institutional facilities or clusters of businesses. How do the cluster septic systems work? The sewage flows to the septic tanks at each residence. Then the septic tanks retains paths and solid waste while it conveys the liquid sewage to a treatment and a dispersal system, and finally to a drain field for soil-based treatment.
Presidential Decree Number 856 Series of 1975 Code on Sanitation of the Philippines. Chapter 17 Sewage Collection and Disposal, Excreta Disposal and Drainage. Section 73 Operation of Sewage Treatment Works. Private or public sewerage systems shall: Letter A. Provide laboratory facilities for control tests and other examination needed. Letter B. Forward to the local health authority operating data, control test, and such other records and information as may be required. Letter C. Inform the local health authority in case of breakdown or improper functioning of the sewerage treatment works. And letter D. Provide for the treatment of all sewage entering the treatment plant. Section 74 Requirements and operation of sewerage works and sewage treatment plants. The following are the required for sewerage works and sewage treatment plants. Letter A. All houses covered by the system should be connected to the sewer in areas where a sewerage system is available. Letter B. Outfalls discharging effluent from a treatment plant should be carried to the channel of the stream or to deep water where the outlet is discharged. Letter C. Storm water should be discharged to a storm sewer. Sanitary sewage should be discharged to a sewerage system carrying sanitary sewage only, but this should not prevent the installation of a combined system. Letter D. Properly designed grease traps should be provided for sewers from restaurants or the establishments where the sewage carries a large amount of grease. Section 75 Septic tanks. Where a public sewerage system is not available, sewer outfalls from residences, schools, and other buildings should be discharged into a septic tank to be constructed in accordance with the following minimum requirements. Letter A. It should be generally rectangular in shape. When a number of compartments are used, the first compartment should have the capacity from 1/2 to 2/3 of the total volume of the tank. Letter B. It should be built of concrete, whether the precast or poured in place. Brick, concrete blocks, or adobe may be used. Letter C. It shall not be constructed under any building and within 25 meters from any source of water supply.
Section 76 Disposal of septic tank effluent. The effluent from septic tanks shall be discharged into a subsurface soil absorption field where applicable, or shall be treated with some type of purification device. The treated effluent may be discharged into a stream or body of water if it conforms to the quality standards prescribed by the National Water and Air Pollution Control Commission. Section 77 Determination of septic tank capacity. The septic tank capacity may be determined from the estimated unit flow contained in Table 1, quantities of sewage flow. Based on adequate detention time interval resulting in efficient sedimentation, daily flow from water results may be used as estimated flow when available. For edifices with occupants, the number of persons to be served shall be computed on the number of rooms, with each room considered as occupied by 2 persons or on the basis of the actual numbers of persons served by the tank, whichever is greater.